All right. Hey, everyone, and welcome to another beautiful day here at GoLab virtually. I hope you all are well. We are about to have a wonderful workshop with Tommaso Visconti from Develer about game development with Go today. So let's bring him on a moment. Fantastic.
Hey,
Hi, Tommaso.
hi, Latara. Good morning.
Yeah, good morning. It's good to have you here. How are you
Thank you.
today?
Fine, thanks. Ready to rock.
Fantastic. Yeah, ready to rock. I like that. All right. So, everyone who is not familiar with Tommaso, let me read a little bit about him. He is a full stack web developer working at Develer. His career started long ago as a PHP programmer and a Linux system administrator, and then as a freelance first, and then as a software developer in Develer after. He worked with Ruby, JavaScript, Python, and more recently, Go. He started exploring this language 3 years ago during a company hackathon. And tired of creating the usual to do project with his teammates, they decided to create a small isometric game to visualize the company's source repositories as evolving cities winning the hackathon. I remember that. After this experience, he continued playing with 2D games that you can find in his GitHub profile before starting to professionally work with Go around 1 year ago. As he enjoyed a lot starting his Go experience with 2D small games, he decided to share his experience in this workshop where attendees will build a game from scratch. So it is aimed at Go beginners that want to start exploring the language, not writing the classic to-do API app, but a simple 2D game using the Ebiten library. So this workshop will be very hands-on, where some slides and explanations will be followed by you writing your own game. All right, so before I give you the reins, was there anything else you wanted to add?
No, I will say everything during
Yeah,
the workshop.
excellent. All right, we'll have the intro and then ready to go.
Thank
Enjoy,
you.
everyone. My pleasure.
Okay, let me share the screen. Okay, hope you can see my screen. Let's start. Okay, welcome everybody. As Latara said, I'm Tommaso. I'm a web developer in Develer, and I started my Go experience starting with this game development, and I really enjoyed it. In the past, with other languages like Ruby, Python, I always started with the standard backend API app, and it's okay, but long it can become a bit boring. So I enjoyed playing with video games, and during this workshop, I will share my experience, and I would like to give you some inspiration to learn Go better, or learn Go if you're just a newbie with the language. And at the same time, you can start writing small 2D games and maybe become better and have maybe a new career in it. We will see together the Ebiten library, or Ebiten, I don't know the pronunciation, is a Japanese library, which is aimed at creating 2D games in Go. And along the way, we can concentrate on some Go core concepts. This workshop is divided into 3 parts mainly. The first will be a bit longer than the others, but we will start always with a small theoretical part, around 15 to 20 minutes. And then I will leave you try what I tried to explain with an exercise that will last around 30 minutes. And at the end, we will have 10 minutes to share thoughts together, reply to your questions, or maybe have a pause just to relax between the exercises. During all the workshop and the exercise, please use the chat on the right. Write questions there. I will try to take a look, or the others folks will try to help me to don't lose any question. This is my the repository I created for this workshop. You should open it and clone the repository. You will find there the assets that we will use to create the game, so sounds and images, and also a lot of examples that I will explain today are there as code, as well as my version of the game, of the exercise that you will try to complete. If you don't have now time to copy this link, don't worry, because I will share this part of the presentation at the end in a PDF format. This is the agenda. It's a bit full, so we will try to do everything. We will start with a brief introduction to how the games work and the game loop, then an introduction to the library, Ebiten, and then we will go deep in the library, so how to draw images, how to animate the images, and what Spritesheets are. If you don't know what they are, don't worry, we will see later. Then we will use user inputs to interact with our game, add music and sounds, and at the end also we will write in our screen game with the custom fonts. And the last part about user experience and the scenes is just a theoretical part on how our simple game would be improved, adding new scenes, and how it could become a, let's say, serious game. Okay, so let's start. How does a game work? This is just a simple introduction. I won't go deep, just to let you understand how the library works. A game at the end is just a program, a flow of code that is being executed. There are many well-known programming patterns that helps the developers to create better games. And the most famous one is the game loop. We will see it now. I linked you that website, gameprogrammingpatterns.com, which is very interesting if you want to really understand how games work. Take a look. So I said a game at the end is just a program, and it has to interact with the user, so keyboard, mouse, joystick, and also play sounds. At the same time, it must not stop, because you want to always see your game, the environment, the characters continue their life. Let's say life. Don't want to stop because the user isn't clicking the mouse or entering some character. So the game loop is the fundamental pattern that helps you create the game. And this is how it works. Once the game has started, the loop starts and it continuously spins, processing the user input, then updating the internal state of the game, so updating all the objects and whatever you have to do to implement the logic of your game, and then it draws all the objects, it draws the game itself until the game somehow ends and everything quits. Each game that you will play tries to run at least at 60 frames per second, which means that one frame, one drawing, will happen every 16.6 milliseconds. The main problem that we have with the game loop is that if you just cycle into the loop one after the other, then the game speed depends on the speed of each part of the loop, which means also that it depends on the machine that is running the game. So older computers will give you a slower games, while faster computers will give you faster games. This is what happened in the past, where, for example, for one of the first versions of Prince of Persia, you should have used the exact PC that was expected to use like a 8086, if I remember correctly, because if you use a newer computer, the games was too fast. The first solution to this problem is to add a delay after the drawing step before starting the loop again. This works because if your loop is fast, because at the end you have to wait some time. But there are two main problems. One, if the game is too slow, you have to wait nothing, and simply the game slows down. And at the end, if you are too fast, you could start the next loop, but you can't. You have to wait. So you're also wasting your CPU power. A second solution, a more advanced solution, is to add another calculation in the update process, where the update, the part of the code that updates the world, all the object, all the states, knows how much time is passed since the last update. And so it can simulate the world. This is different from having the update every 16.6 milliseconds, because you don't know how much time is passed. You have to calculate. This sounds good, except that, for example, think to a character that is running through a door, for example, and for some reason at that point the game is slow. When the update step calculates the word, it simply doesn't know that there was a door there, and the user probably is go after the door, like a door not existing. Or think, for example, to a game, first-person shooter, where you shoot people. If there is some slowness during the game, probably bullets can go through the other characters without hitting them, and this, as is obvious, doesn't work. So the final solution, that is the one solution used by Ebiten 2, is that the loop is split in two smaller loops. One loop is the update loop that runs at fixed speed, 60 frames per second, and processes the input, the user input, like keyboard, mouse, whatever, and then it updates the object. Using fixed speed, you don't have the problems that we've just seen. At the same time, we have another loop, which is the render loop, that renders when it can. It tries to maintain 60 frames per second, but if for some reason it can't because it's too slow, there's no problem. We will probably see a glitch in the UI, in the characters, something like that, but there's no problem with the physics, which is the most important thing in games. Okay, after this introduction, I hope I was clear. Let's see what Ebiten is. This is on the right. You see this picture. That's an Ebiten in Japanese. I discovered this. Okay, Ebiten is a game library, that 2D game library that has been developed by Hajime Hoshi, and it's based on simplicity. You can find Hajime on its Slack channel. I linked the URL at the end of this slide. He really is always present and is very helpful, and will help you if you try to ask something about Ebiten. In Ebiten, everything is considered an image, and most of the operation that you will do during your game development, for sure today, consists in drawing and moving images around the screen. The API is simple. The API reference link is in this slide too, and it's very clear. And fantastic thing is that Ebiten can work on desktop, so on your computers, as well as on mobile phones or iPads or whatever, and also on web as a WebAssembly. It's very simple, and you can, with small changes, use the same game everywhere. Okay, so start with the code. To run an Ebiten game, It's very simple. You just have to implement the ebiten.game interface, and then you have to pass it to the ebiten.runGame function. If you don't know what an interface is in Go, the Go interface, its definition is that they are just named collection of method signatures. This means that an interface is a piece of code that describes how an object must behave, not what an object is. And similar objects can have similar behaviors, and then they can can implement the same interface. Here we'll see together a small example. This is an interface that describes a flying object. A flying object can, for example, take off, can land, and can have its own altitude. If you want to implement this flying object, for example, we could have a superhero or a rocket that are different objects, different struct in Go, but both can have the same behavior and so implement the same interface. In this case, you can see that the manage fly function, it's called twice, once with the superhero pointer and the other with the rocket pointer, but in its signature, it's accepting a flying object. It's not expecting to have a rocket or a superhero. And this is very cool function of the interfaces. Okay, so now after this really quick introduction to interfaces, jump back to the code and see how this is the smaller game you can have in Ebiten is implemented. So we have a main function when we just set the size of the window that will be created when we run the program. We set the title, and then we, as said, call the runGame function, passing a pointer to the game. The game struct is different from the game interface that is declared by the Ebiten library. It's our own game. It's a struct here, not an interface, and has these three functions: update, draw, and layout with these signatures. This is what the game interface into Ebiten declares as its methods. So the update function, it receives a screen image that can be totally skipped because it's a legacy behavior that it's there for backwards compatibility, but you can ignore it unless you really need it. It receives a screen, updates all the internal state of the game, and returns an error, if any. The draw function instead uses the screen because it's the function that really draws images and objects into the screen. We will see later how to draw images. The layout function simply gets the outside size of the game. In case of desktop, is the window size that we just set in the main function, and then it returns the game logical screen size. If you return exactly the same inputs you get, if you define, for example, a screen by, I don't know, 640 to 320, you will have that window with a pixel of your images that corresponds to a pixel of the screen. If you, for example, returns half of those sizes, or each of the pixel you draw will be twice its original size. And this is what I say in this slide at the bottom, that it can be fixed essentially, and what I suggest for this workshop. Or in case you, for example, have a mobile phone that can be moved in different directions, then you probably want to make some calculations. Okay, let's see how images works here. Everything, as I said, is in image, starting from the screen itself that is passed to the draw and update function. And what you always do while developing games is just to draw images, one over the other, which means that the order of the images when you draw is important, because the last that you draw is the most near to you, what you see in front of the others. This is just a list of methods that can be used in the Ebiten library to create images. We won't use all of them today. This is just the full list, but we will use 2 or 3 of them. The image object has a lot of useful methods that are all at this URL. Remember, I will give you this slide at the end of this part. The simplest thing that you can do with images is just to fill them with colors. In this case, we are that's the red color, because the RGBA color means red, green, blue, and the alpha channels that goes from 0 to 256. In this case, we are filling the whole screen with the red. At the bottom, instead, we are generating a new image, 100 in width and 100 in height, and then we are filling it with blue. And then we are drawing that image, you see the last line, over the screen. Okay. The second argument, let's go back for a moment. The second argument of the draw image function is the image option, that it's nil in this case, but can be used for almost everything you want to do with your images. They can change the color, the geometry, as well as composition and filterings of images. What we will use today is translate. We can use rotate and scale. And this is inside the geometry of the image. In this example, for example, we are defining the draw image options, and then we are translating the image 50 pixels on the right and 100 pixels on the bottom. Remember that in Ebiten, the origin point 0, 0 is in the top left corner, and the y direction is toward the bottom, while the width, the x, is on the right. Then we are rotating the image by 0.5 radians and scaling by half of its size. And then we draw as we've seen before, but passing the options too. All you can do with geometry is in the URL that I link here. So what we've seen so far is enough to draw this image. We have drawn a red color, filled the screen with a red color, then created a green rectangle, and then a blue rectangle that has been moved and rotated. And in this example, I also added some transparency. This full example is at the URL link here. All the examples are in my repository, that folder, into the examples folder. Okay, step forward, we will draw this image, which is a simple coin. Then in the next part, we will see how to animate it. To load an image into Ebiten, there are a lot of functions, like the one that loads directly a file. The simplest way, in my opinion, is to use this command that is provided by Hajime himself, the author of Ebiten. You see the link on the bottom right part of this slide. Once you have installed it with go-get and the package, you will have this command that can get anything, any file as input, in this case an image, and can output it in a file, the assets.go file in this case, adding also the package, and defining a variable, coin.emg in this case. What this program does is to load the bytes into the files and saves them as a variable in Go. This is very portable because using other functions can be different depending on the device, desktop, mobile, web. With this file to byte slice, these methods works in every device. Once you have generated the assets with the step we've just seen, this is the way to generate an image. in this case, to simplify, I just defined a global variable coin. And then I decoded the image, reading the bytes, and then I use the new image from image function from the Ebiten library, passing the filter default, which is essentially filters are legacy now in Ebiten, so always use Ebiten filter default. The image that you have at the first line of the init function is the image coming from the standard library. Image.decode is a standard library function, while the second function transforms that image in an Ebiten image. Another point on this function is the init function. If you don't know what is that, if in a Go file, in a Go package, you have an init function that is executed before the main, when the file is loaded. So it's a good place to initialize a lot of things. If you are more expert programmers, you probably want also to do this type of initialization into constructors that you will define on your game, but this is another topic. Here, it's a Java function that moves the image at the center of the screen. So I can let you see how to use geometry. We define the options. We get the size of the coin image and the screen image, and then we translate it at the center of the screen. I created, yes, a small chart to let you understand this translate line. You can see I pass two floats on the X and the Y to move the image. How it works, essentially, if you move on the right and bottom by the half of the size of the screen, you get the image that is a bit transparent here, because the 0, 0 point of the image is at the center of the screen. But then you want to move the image, the whole image at the center of the screen. So you have to go back and left by half of the coin size. And this is the result of this program. And you can find the code at that URL. This is just a parenthesis on generators. As you've seen, I've generated the asset with the file to byte slice. There is a way in Go to automatize, probably, how to generate files, and this is how it's done. You create a Go file, in this case generate.go, where you add on top a comment like this, / go generate, and then the command you want to run, and you can add multiple commands. And this is very useful in our case because we will have many assets, and we can create just this single file, add the commands here with the go generate dot in the folder where this generate.go file is. It will run all these commands and generate all you need. Okay, I hope I've been clear enough. We will see how we can start practicing what I've explained now. This is what I would like to create during this workshop. Is a shooting game where there are ducks entering from the left. You move your mouse, moving also the crosshair, and then you can hit the ducks, gaining some points. What we have here, I hope you can see my mouse. We have curtains on top and curtains on left and on right. Then we have a desk on the bottom. This wood here is a background, and then ducks. I didn't use in my examples the gun and other things because it's too complex for these 3 hours. And while the curtains and the desk are steady, the waves will move. We move in a wobbling way, right, left, and up and down. Ducks will appear from the left and go right. The speed is up to you. And the crosshair will make you see where your mouse is, so you can hit the ducks clicking. and when you hit the duck, we will play a sound, and also if we miss a duck, and at the same time there is a background music. Moreover, we can, if we have time, add a score. You can see it here on the top, like 10 points if you hit and minus 5 points if you miss. Okay, in the repository that I linked before and that I will link in the chat here in a moment, you will find an assets folder with this PNG folder with all the images there. There are also other images in Spritesheets, but we will see that later. What you need for this exercise are these files: the background green, the curtain straight, and the background wood. And this is the result that I would like to see at the end of the exercise. The background, the desk, and the top curtain images, these three are not big enough to fill in the whole screen. So what you have to do is to get the size of the screen, get the size of the image, of each image, and find out how many times you have to repeat the image in both directions to fill in the whole screen. Remember that when you repeat an image, which means draw an image twice, the second time you have to move it on the right or on the bottom, the size of the previous drawing. So at the end, you fill in all the screen. Another thing to note is that the curtain on the right is the same image as the curtain on the left, but is mirrored. And to mirror an image, the instruction is this one here, geometry scale -1, 1. If you have some extra time, you can see I added here a very small border to simulate the top of the desk, which is simply a brown rectangle on the top of the desk image. If you really have more time, you are very good, you can also try to add a small shadow below it. A shadow means that you have to draw many black rectangles, one below the other, decrementing the alpha, so adding more transparency. And to do all this exercise, you just need the draw function, not any other function in Ebiten. Okay, so you can start. I will link in the chat the URL as well as the Ebiten home page. And here on the left, you can find the API reference where there are all the functions used. And I will also send you the slides of the slides you've just seen. You can download and use as a reference. If you have any question, please write. I will try to answer to all the questions. During the exercises, if you are stuck somehow, don't lose too much time, just write and I will try to help you. We can have private chats. There is this question and answer chat on the right with the question mark, or in case I can reply there, or if you want, you can share your screen and ask the question for everybody. Sorry folks, I interrupt you just to add, I think I forgot to mention, when you import your image, you decode the image. Remember, you have to import the correct decoder depending on the image format you're using. In this case is PNG. So you just put this import on the top. The underscore here means that you don't need to use it. You are not assigning this import to a name that you can use in your code. You just want to import, so its initialization function will do what's required to decode this image. I created a brief quiz just to know what are you doing, how it's going. I think you can see it. I will ask help to the Develer guys, to the GoLab guys. How can I share with the others? Okay, you should see. So you should see it. If you want to share the status of your development, you can reply to the questions. Still 10 minutes to go. If you have any question, please ask in the chat. I'll try to answer immediately in the chat or later. All right, folks. I would like to start this small session of question and answers. If you have any, please write to the chat or ask the GoLab organizers to. Okay, Latara is joining, so she can explain better than me.
Yes, if anyone has questions, you can, of course, use the Q&A chat bubble. That's a good place to keep things organized from general chat. So if you do have questions, we'll ask them now.
If you didn't complete the exercise, don't worry, because the next exercise will be a continuation of this one with other stuff, so you can complete what you are doing now before starting the next exercise.
Sounds good. It seems like there are no questions so far, so
Okay. I would like to start the next section, and then we will have a pause at the end of that. So
sounds good.
sounds good. Okay, so let's share my screen. Okay, you see my screen, right? Give me a signal of some type. Yes. Okay, let's go. So let's start with animations. Since now we've just drawn static images, but as you probably know and want while playing a game, you need something moving in the screen. And this is an example on the right of a small game made by static images animated. An animation is just a sequence of static images, one after the other at the given speed. A common way to animate images is to receive an image like this one with many images, the frames of the animation, one near the other. In this case, all single frames have the same size and are one near the other. To animate an image, we need some simple state. In this case, it's just a counter, is a tick that you can add to the game struct, and then each update will increment that tick. It simply gives you the idea of where you are in your game, in the timing of your game. As I said, this image has a fixed size frames. So they are 16 pixels, and so each frame is just a movement of what you are seeing, 16 by 16 on the right. The height is fixed, so you don't have to change the height. You just have to create sub-images moving your view. And when you are at the end of the animation of the frames, you have to start again from the beginning. So in this case, in this example, I define two constants. One is the size of the image, as I said, is 16 pixels, and the other is the number of the frames of the animation. The draw function, here when we get the number of the frame we are at, using the tick modulo the total number of frames. And then we have to know how much on the right, on the X direction, we have to move. We have to move the number of frames we are at multiplied by the size of each frame that is fixed in this case. Then we can define a rectangle. Starting point is 0 for the Y and this frame X for the X, and then is 16 pixels. This is a calculation, but we start from these 2 points, frame X and 0, and we add the image size. In this case, it's 0 plus image size. So we obtain a rectangle 16 by 16 mapping the right frame in the global image. We then create an image as a sub-image of the original spreadsheet with the image with all the coins of the animations using the rectangle we just defined. And then we draw this image, this sub-image. As sub-image returned by sub-image is not an Ebiten image, but an image interface from the standard library, we have to make this type assertion. Type assertion means that we know this is an interface, but we also know that it behaves like an Ebiten image. So we can use this dot parenthesis and the type we want to transform it to. Remember that if this is wrong, as this is a runtime command, it will generate a panic if it's wrong. You can use another form to check if this sub-image behaves like an Ebiten image. And this is the result. You can see it's almost correct, except that it's too fast. Too fast because every call to update, which means 60 times per second, we update the tick. And so we are spinning this animation too fast. To get a correct speed, where correct is what you define as a speed for your animation, we can add this speed value to our game and then divide the tick by the speed. In this case, we use 10. The calculation is, remember that you have 60 ticks per second, and you have to decide how many ticks, how many frames, 6 in this case, you want to see during 1 second, and you get 10. 10 is the speed of our animation, and this is the result, which is correct. We can try with other numbers to have slower or faster animations. And you can find this example here. It is the example number 3. Going to something a bit more complex, we go to complex spreadsheets. Here on the right, you can see this is the spreadsheet from MetaSlug. I found this on internet. I can share the link with you later. And this is just a part of this spreadsheet. It is a huge image with all the possible animation movements of this character, Marco. And you have to animate this spreadsheet, but as you can see, not all of them have the same size and they are spread in the whole file. This is because to reduce the global size of the final file. So as I said, things get a bit more complicated when the frames have different sizes or are not one near the other, but spread across the whole spreadsheet image file. In this case, you generally receive a specification file, can be JSON, for example, or other text formats, and you have to read the origin point of each image and its size from that file. At that point, you can build, as we've done before, a rectangle to get the image you want, the frame you want, and then use it. Spritesheets are not just for animations. You will find in our assets folder this spreadsheet here on the right can be used also to use bigger images with all the single assets inside it. This is something that optimizes the final dimension of the images. And also in this case, although you don't have to animate, but you have to read the specification file to know where the image is. And this is just an example of a possible JSON file with the specifications of the images. There is a initial frames key with a list of images. Each one has X and Y as the origin point and the width and the height of the image. now we'll see together how we can process this specification file. And remember that this is just an example. You can find multiple different types of these specification files. You have to adapt your code to them. If you don't find a specification file in an asset folder that has been given to you, but there are spreadsheets there, you have to calculate by yourself with some image software like, I don't know, Photoshop or something like that, and pixel by pixel calculate your frames. It's not a funny job. Okay, so as we've seen, this is the specification file. We want to read it with Go. So I define two structs, one for the external frames key, frame spec here, and it has a frames element with a slice of frame spec object. In this case, they contain X, Y, W, and H. An example to add this to your game can be to define a frames object as a slice of frames in your game, and also the total number of frames for the animation. You can also calculate this total number every time, every update or every draw, but as it's always the same number and is a heavy job, you can just do that once. And this is an example of a function that reads the JSON file. Reads the JSON file with the IOUtil read file. It receives the path to the file. It also defines a variable fspec as pointer to our object here, this frame spec here. And then we just unmarshal the JSON file we've just read to this object. This makes the fspec variable object to have all the data into the JSON file. At that point, we can assign the frames to our game frames and calculate the length of frames. This is just a way to ask the user when the program is executed to send the path to the JSON file as a command line argument, and then it's passed to the build frames function. At this point, the function is very similar to what we had before. We calculate the frame we are at with the same calculation, tick divided by the speed, and modulo the number of frames we just calculated from the JSON. The frame we need at this point, the frame that has the dimensions of the image, must be loaded from the frames slide, knowing at what frame we are at. So we can define the rectangle with the X and Y of our frame from JSON, as well as the dimension H and W and H. And then, as before, we define a subimage and we draw the image. And this is the result. It's not optimal. What's the problem here? Is that we are drawing always starting from the 0, point, but the images have different sizes. So the animation is wrong, is just on the left, while we have to find the center point of our animation. In this case, for example, we are moving that coin at the center of the screen. Very simple calculation. We get the X and Y of the screen, and as we've done before with the static coin, we move it at the center of the screen. This is done using the center of the screen, but these X and Y can be any point you want to use as center of your coin. And this is the end of our animation. Okay, this was a smaller part because I know that you have to finish also the other part. This is the exercise number 2. What we have now is here on the left, or what we should have is on the left, and on the right you can see what I expect to have at the end of this exercise. The assets that you need for the exercise are just two, the water and the duck. You will see in the PNG folder there are many variants of the duck. Use whatever you like the most. The goals of this exercise are that now the movements of the object, the object will move, and the movements are both on the X and the Y directions, both up and down and right left. To manage these movements, you can try to use a multiplier that is in my example +1 and -1, because as you probably imagine, you are moving using the geometry in one direction adding and the other direction removing some pixel to the position. Moreover, while the ducks just move from the left to the right, the waves must be glued one near the other because they are small and must complete the whole screen horizontally, and they must move right, left, up and down. Consider that when they move here right at the beginning, if you don't add an extra wave out of the screen at the beginning, when the wave moves right, you will see a hole in the waves because you didn't attach an image on the left before starting the animation. Okay, ducks are generated randomically. This is how you generate randomic stuff in Go. You have to define a seed. This can be done in the main or in a init, wherever you like once. And then this is just an example. If the visible ducks, which means the number of ducks in the screen, are less of this max number of ducks that I would like to see in the screen, then I generate one. But I don't generate always one. I see if the tick modulo 60 is 0, which means every second, I see if I define a 30% possibility to define a duck. You can use 40, 50, which means that you never generate ducks at the same pace, but I add this randomic generation timing. And then I add to ducks, where ducks in this case is part of our game object, but you can define a global variable, whatever you like. I define a new constructor, new duck, that generates a new duck, and then I add to the visible ducks. This is a way to remove a duck here. When a duck crossed all the screen and is out of the vision, which means that its originating point on the X is bigger than the screen width, at that point you have to remove the duck from the list of visible ducks. To do this, this is a trick. You can find handy tricks on slices at this URL. What you do is loop over all the ducks. If, as said, the position of the duck is out of the screen, at that point you remove it. To remove, essentially we define this index out of the for loop because you are removing elements from the same slice we are ranging on. So we define this counter outside. If the duck position is outside of the screen width, then we add the visible duck at the correct position. We increment the n, the counter, and then at the end of the loop, we reduce the visible duck slice to only the active ducks. Some extras if you complete the job quickly. You can try, instead of using single images, to load the images from the Spritesheet. You will find them in the assets folder, and you can find a logic yourself to get these images using the name. The image name is the same as the single images, so you can know which image you have to load. All the constant you used, like the speed and so on, try to extract them from within the function and add, for example, as global constant. So you have all of them at the top of your code and you can easily adjust them while making your test. If you have more times, DAX could have also a stick below it to simulate a real Luna Park game. And also they can maybe rotate a bit while moving. Okay, this is the exercise. Okay, you can start. If you have any question, please ask. I'm here to help you. At the end of this section, this exercise, we will have 5 minutes, 10 minutes of pause to stretch your legs and drink something. Oh, I forgot. I will send here the link to this second part. I found an error in this slide, so I will tell you before you copy the code. I used bigger than, but in this case it must be minus or equal to, or sorry, or it won't work, because this for loop checks all the elements that must remain into the final slice, not to be removed. 20 minutes of this exercise, folks. How is it going? I'm going to share another survey as before. I like these surveys. Start. Let's see. If you are trying to understand how to move up and down and right and left, and you don't want to ask a direct question, I'm going to share here the lines of code where my exercise calculates how to move ducks. Maybe you can try to get inspiration from there. I'm opening the issue functionality in the GitHub repository. So if after this workshop you want to ask questions or whatever, you can just create an issue and I will try to give you a feedback. Okay, half an hour is gone. I hope all of you are at a good point. If you have any question, please ask either in chat or live. If not, we will have good morning, Latara.
Go ahead. You were saying?
Oh yeah, I was saying that we are having a small pause, like 10 minutes. We will start again at 5 minutes past 2 p.m. here in Italy. I don't know, yeah, what time in your time zone. Let's wait 10 minutes. And if you have any question, please ask. I will be here to reply.
Perfect. As Tommaso said, everyone, we'll take a 10-minute break. So see you again at 5 minutes past the hour. All right. Get some coffee, maybe. Great.
Thank you, Natal.
Hmm. Okay, everyone, it is 5 minutes past the hour, and we are ready to do the second half of the workshop. So hopefully you are all refreshed, energized, and ready to begin. Let's go ahead and have Tommaso come back on.
Can you hear me?
Perfect. Okay, there you are.
Okay.
So take it away.
Okay, let's start again with the presentation. Hope all of you have reached a good point in the exercise. This is the last part. We will see some extras, and then we will try to complete the exercise. Let's talk about user inputs. The first one is the keyboard, and in this case it's very simple. Ebiten gives you this isKeyPressed function that expects a key. In this case, the key is a new type defined by Ebiten, and there are many keys, one for each key in your keyboard. And as you can see here, you just check if the key is pressed and then do your action. This is done into the update function. Remember that the update part updates the logic after it has received the user input, while the draw function draws the game state. Defining a new type as the key in Ebiten is something that we've already seen for structs, that is very common, but can be done also for other basic types in Go. In this case, for example, before I said you could use the multipliers +1 and -1 to change the direction of your ducks or of the waves. You can also define a new type called direction that maps over an integer, and these new constants, sorry, like right, left, up, and down, and they are directions. The cool thing about these custom types is that you can also add functions to them. In our case, could be an invert function where if you go right, you then go left, which is very simple if you use the +1 and -1 multiplier, because you just have to return minus the value that you already have. And this can be applied in our game too. It's just some mathematics applied to the game. And this is an example to apply this logic to our game. For example, the duck or the wave can have a direction, the y direction, to move up and down in the screen. And if we have a max position for our duck, top or left or down, sorry, you can just invert its direction, and so you will see the duck moving the other way, the duck or the wave. The same applies for the mouse. There is this function, is mouse button pressed, that gets another type. In this case can be a mouse button left, right, or center. And if it's true, it returns a boolean. If it's true, you can do what you want. For example, in our case, can be the shooting action. And once you know that the user is shooting because he clicked the mouse, then you can get the cursor position, the position of the mouse. The position of the mouse is always relative to the screen of the game. So 0, 0 cursor position is top left of your screen. And then you have to calculate where it is into the screen. We have let's say a problem. Both inputs, keyboard and mouse, will be triggered at every time the update function is executed, which means 60 times per second, which is a lot, because also if you really click for a very short time, it could be intercepted several times. And for example, if you want to move every time the user clicks on the right in the keyboard, just one click could lead to a very big movement. In this case, you want to add a debouncer, what's called a debouncer, which is a way to compact multiple inputs to a single one of using an amount of time. And this is a way to do this. I define a debouncer lasting 100 milliseconds, can be 200, 300, depends on what you want to do. And then I intercept the key. If the last click I had was happened in a greater time than the debouncer, I accept the input. Instead, I just ignore the input. If I accept the input, and you can see here, I check both that the key is pressed and that the current time, I subtract the last click I had to the current time must be bigger than the bouncer. In this case, I reset the last click I had. Not that I'm using last click at that when you use it the first time has a zero value that is zero, very old in the past. So I don't have to initialize this value the first time. Okay, it's very simple for the keyboard and mouse inputs. There are also other inputs like touching on touch screens or gamepads. They are a bit complex. We are not using them now, but the essential of getting those inputs is that you have multiple gamepads and multiple touches. You have to index them by an index and check all the index you have and see if you had any input, but we won't see them now. We now talk instead of music and sounds that we need to add to our games. So Ebiten can play sounds very easily, is very straightforward. All the sounds you want to play in your game must share the same audio context. We will see how to initialize an audio context. You can't initialize an audio context more than once. The audio context defines the same sample rate of your streams, of audio streams. It must be the same for the streams that you are going to play, but it's not a real problem because the decoders that we use for WAV or Vorbis or MP3 automatically resample all the streams to the sample rate of the audio context. So you don't have to take care of having all the same rates for all the stream. Once the context is defined, you just have to play audio streams on it. And if you have multiple streams playing at the same times, like multiple sounds in the game, there is no problem because Ebiten automatically mix the sounds for you. You have only to take care of not playing too many sounds because you can get some distortion. There is no explicit number of sounds that cause distortion, but in the manual you can find don't play too many. And here the link to the audio package, which is an extra package of Ebiten with the function that we will see now. As for the assets, we have to import the files. As for the images, I suggest to use file to byte slice here too, because it's very simple. You don't have to import files in different ways. You just generate your files as the images. Then you have, as I said, create your audio context. I'm using here a global variable. As said, it must be once for only one for the whole game. You can also use it as a variable of your game, you choose, but in this case it's very straightforward to use a global variable. And then in the init function or the main function or whatever you like the most, you can just define this audio new context, passing it the sample rate. In this case is this megahertz value. Now we see how to play background sounds or single sound, like can be when you hit a duck. This is a background sound that is a music. This ragtime sound is a OGG, which means Vorbis file that you can find into the assets folder. And in the first line here, OGG, you have to decode the Vorbis stream. And to do this, you have to import the right decoder. In this case, this Vorbis can be Wave or other decoders you can find in this audio package. You pass the function, the audio context, and the stream of bytes read from the file you just generated with the tool to generate the byte slice into the file. At that point, you have to define a new infinite loop that takes both the sound that you have just decoded and its length. In this case, I use the old sound that must loop when the song ends, it becomes again to play. You can choose, for example, with some variables, if, for example, this stream has an intro or an outro, you probably want just to use a loop for the central part. There are other functions to do this, but essentially, in our case, we have a long music that ends, and then you can start again. What you receive from this new infinite loop can be passed to the player that can be created with the audio.newPlayer, passing again the context and the stream. And then you run the play function on it. You can run this at the beginning of the game, and we will go and go and go. A bit different for sounds that you want to play just once. In this case, you decode. This is a wave, it's not a Vorbis. You have to import the correct decoder. For the rest is the same. You don't need this middle function infinite loop. You just can pass this sound to the new player, and then you have to play it. Every time you play a sound, you have to rewind it. This is standard. Every time you have to play, you just rewind and play. If it's the first time you play it, it's already rewinded. There is no problem to call this rewind before playing. Done with sounds is very simple. Let's see how we can add text to our games with custom fonts. This is the example you can find in my folder. You can, when you create your text in the game, you can use images for sure, and in the assets folder you will find also the numbers you can use for the score, but at that point you have to create an image for every letter you want to write, every character. You can more easily, if you want, use fonts, custom fonts that can be TTF fonts downloaded from wherever you like. In this case, you will find attached to the example a TTF font I got from DaFont. Is a GPL font that can be used as you like. And here in the bottom, you see this is the package, the text package from Ebiten, where you can find the functions. Functions are just two, are very simple. Again, the font can be imported into your game with a file to byte slice. You see through all the slides that I always use this file to byte slice tool, because as said is the only one that is guaranteed to work on every device you are going to use Ebiten. So I really suggest to always use this. And at that point, you define a font. You parse the font asset that has been just generated, and then assign to your variable this TrueType new face, where you have to pass it the font just loaded and some options. In this case, the size and the DPI of the font of the screen. To use it is very simple. it's just one line, is the second one. You have just to draw, this is the function, over the screen, a text, in this case, hello gophers, can be whatever you like, with the font you just defined, the position can be 00 or whatever, and the color of the font. I also added this bound string, which is the only other function present in this package, and it's only present in the more recent version, that can be used to find the position of your text. As you see here, I just put 10 and another variable. Can be a number you calculate yourself, or you can use this bound string that gives you the rectangle containing your text. And at that point, you can use this bound variable with many methods inside to calculate how you like to move in the screen. It's not so easy because I found out that fonts have a very complex way to calculate the position of the fonts. Essentially, the golden rule is that if your font is just a dot, which can be seen here as origin, and you put it in 00 or 1010, 100, 100, that in the right position where you expect to find as an image. If the text is bigger, is complex, like in this case, there is really a lot of stuff to calculate if you want to really pixel position your text. In my experience, which is not so big, but I wrote some text in my games over the time, the best way to position it is just to make some attempts. You know where it has to be, but then you have probably you need to move it a bit in various directions to find the correct spot. This is the last part of my slides, and I would like to talk with you about user experience and multiple scenes, because this is what can transform your game, which is very simple now, it's just a draft, to something that can be defined as a complete game, although simple. But when you play a game, you expect to have some launch screen or other screens like options, leader scores, whatever you want to see in your screen, as well as some and text when you complete or when you die, like game over, something like that. And this can be done adding some more user experience to your users. A UI is just as we can see here in this sample image, is not different from what we've done since now. We have images, we have text, and we have to position them in the screen. And this is something you can do by yourself, finding the correct images, buttons, and so on, and then intercepting, for example, the button of the click of the mouse for the start or whatever. At that point, you probably want also to add other things that we won't do in this game unless you really have a lot of time. That can be, for example, save the game state. That can be stored in local files or online or whatever. We are not going to this topic now because it's too long, but a simple way could be to save all your game state, for example, to a JSON file and save it on your disk containing, I don't know, the score of the users and so on. When you start adding a UI, you are also probably starting to think to multiple scenes. That can be a start scene, then the game, and option scene, and so on. There is no rule. I just want to share something that I thought while thinking to this presentation. This could be a way to define the scenes. For example, in this case, I define a scene struct, and there we can add all we need. For example, all you are doing now for your exercises could be saved into this scene struct. At that point, the game that I think in this moment in your exercises probably is holding all your images, all the sounds, everything can be can hold a list of scenes. In this case, I use just a map with pointers to scenes and an active scene that is the key of this map. So the game can know what to draw. Here you can find in my repository a very small example with two scenes. Each scene defines a button, a background color, and what to do, what scenes jump when you click the button. And this is what I just described. Our scene has an image, the button, the background color, and which will be the next scene that holds the key of the map. This can be done, for example, in the update function. There is a scene, which is the active scene in this moment, and if, for example, the mouse button of the scene is pressed, this is just metaprogramming. A lot of stuff is missing from here, just to give you a rough idea. If the mouse is pressed, we intercept the cursor position, and if we see that the user just click over the button of the image, we can define the active scene with the next scene. At this point, at the next update function, we will have a new scene, and the draw function will draw the new scene. This is very simple. There is no animation between scenes. There is a lot of stuff that can be added here. It's just to give you a rough example. The draw function at this point, as you probably already have understood, doesn't contain any logic for the state of the game. Changing scene is just something that it is inside the update function. The draw function just loads the active scene and makes the action that are expected by the scene, fill in the background and draws the button. You can see here, translate the button in the center. There is, as I said, there are parts that are missing that you can find in the example in the repository. Okay, so I think I talk maybe too much. Let's see how to complete our game. What I would like to ask you for the next exercise is to transform what you should have now here on the left to what we will have on the right, including sounds. So the goals are to add a background music. You will find the ragtime file, OGG file, in the assets folder. Draw the crosshair. It's an image. Its position must follow the cursor while moving in the screen. Then you can define a global score, and when the user clicks, if the user clicks over a duck, then it will gain some points. If, for example, this is an extra, he misses the duck, you can remove 5 points if the score is bigger than 0, obviously, and then you can also write the score here with custom fonts or using images. To understand if the user hit a duck, the simplest way is to approximate the duck as a rectangle, the rectangle of the image of the duck. If the click is over the rectangle, you can consider the duck as hit. The assets you need are the crosshair, white and red crosshair, the custom fonts that you can find in the font example or into the DaFont website or whatever you want to get your fonts, or you can use the images that are text 0, text 1, and so on into the PNG HUD folder. Then the heat wave and mist wave sounds, and the ragtime OGG file, which is the background music. if you have spare time at the end or for extra exercises for home after this workshop, you can also add more scenes like an initial scene with the play button, an end of the game. You can define your end of the game in many ways, like when the user reaches 100 points or after some time and so on. And at that point, you can show a game over button with play again. Sorry, game over text with the play again button. And if you want, you can also implement a leaderboard where the user is asked to insert his name or initial letters of the name, and then you can save this leaderboard as state in the game, or if you want, also in a file that you can load every time the game starts. Okay, this is what I have. Again, if you have any question during the exercise, don't be shy. I'm here to help you. As said before, I opened the issue functionality in GitHub. So also if today, tomorrow, in the next days, you have questions, please ask. And if you want to share your code, you can send here the link to your GitHub. And so everyone can profit from taking a look at it. Thank you. I'm waiting for your questions.
All right, fantastic. Well, I hope everyone enjoyed that. I wish I knew how to do this so I could create my own. That sounded really interesting.
Thank you, Latara. I'm sharing the last part of the slides, and also I just uploaded all the slides in a single file in the repository, if you want.
Fantastic, thank you. So hopefully everyone who didn't finish today, you can get in touch with him if you have questions.
Yeah, sure. Thank you.
Fantastic. So yeah, let's go ahead and go towards anything else that people are saying. Let's see here.
Okay, let's wait for questions while they make the exercise. So
Yeah,
I will be here until 3 p.m.
Yeah. And how about this? Since we did have some questions that were asked from the participants that you also answered in chat while they were doing them, is it okay if we read those questions again, just so that people who are watching the video later can understand?
Okay, let me
Yeah, let's
find
do
the
that.
questions.
Sure. So I'm starting. Okay. Okay, so our first question is from Ard, who says, is it normal the CLI tool is not installed when I ran go get GitHub and paste it?
I suggested to use the file to byte slice command to generate the assets as you've seen in the slides. And he had a small problem because using go get of the package didn't install properly the tool. So a good way is to clone the whole repository and then go install it. And at that point, in your go path/bin folder, you will find the tool. And yeah, it worked for him.
Fantastic. Let's see. Another question also by Ard. He said later, do you have the all byte vars in one assets file or one asset go file per byte var?
Okay, yeah. I use different files because the tool file to byte slice once when you run it, it creates a new file with your variable. You can't use it to generate multiple variables in the same file. But if you don't use that tool and do everything by hand, you can also just use a single file.
Awesome, thanks. Another question from him was, how do you then run your code, the full game he meant?
Yeah, I linked my command folder. I generally use this pattern that is used very often in Go softwares where the root folder of your repository generally doesn't contain the main package, which is the package that creates the binary. But you define a CMD folder with another folder with the name of your binary, and then you create your main there, linking all your files or your packages that you wrote in the root folder of your repository or other folders. So essentially, the main function is just into this CMD subfolder.
Okay, thank you. Next question I see here from David Johnston, who asks, how did you generate the JSON files for the Spritesheets? Was that a manual exercise, or do you have a program that helps?
No, I don't, but he suggested a very useful website that I didn't use but seems to work. Essentially, as I said during the slides, you get the JSON files or specification files together with the spreadsheets. If you don't get this file, you have to build your own. And to build those files, you have to essentially count the pixels into these files. And it's a very long job and very boring job. But he linked a website that I can.
Codeandweb.com. Yeah.
Okay, yeah, I
Great.
just opened briefly and it seems cool. You can probably use it for generating these specification files.
Awesome. So I put that in the chat in case anyone who didn't catch it earlier wants to check it out. And I think that was it for all of the questions. So we can actually, I don't know, what do you want to do? Do you want to stay a little bit?
I will wait at the end of the exercise until
All right.
3 p.m. and let's see if the attendants have questions.
Sure. Maybe another progress quiz if you want. It's
Yeah,
up to
I
you.
will wait 10 minutes and ask the people how it's going.
All right. Well then, I'll let you all continue working. Buon
Yeah,
lavoro. Good work,
grazie Latara.
and we'll talk again soon.
All right, folks, just the last survey. I would like to know by you at what point of the exercise you are, if you could complete the first and second exercise, and how is going this last one. Thanks for your answers. As we are reaching the end of our time in 10 minutes, I just would like to ask you to check also my solution in the repository. There is the shooter game folder. You can check it, compare with your solution, uh, take inspiration, or also give me inspiration, because I always want to learn new solutions, creating an issue. Thank you. I just shared in the chat a link to a website containing tons of spreadsheets with images from famous games like Metal Slug or just other spreadsheets. You can use those for your games. While we are waiting for the end of the workshop, I wanted just to share this slide that I skipped during my presentation. It's just an example of a 2D game that simulates a 3D game, in this case, the famous StarCraft game. This just to give you the knowledge that also if we are talking about with Ebiten about a 2D game library, this doesn't mean that we cannot simulate a 3D world like this one in this case. This is called isometric, and I will give this link in the chat now because it's very useful if you want to generate an isometric game. You need obviously isometric assets, but also movements of the game of the objects change a bit.
All right. So we are just about finishing up with the time here. We'll give everyone another opportunity to ask any questions. I would assume no from this, but who knows? Maybe there are some last minute ones. So we'll definitely keep it open a few more minutes. Another thing I wanted to say is we are actually having the Q&A with the Go team. So if you all who are still here have not already filled out the questionnaire, you can ask questions that haven't been answered yet or haven't been asked yet, or you can vote on the questions you want the Go team to prepare for. So that's happening in about an hour and a half. So stay tuned for that. We are also having a recruiting session by Develer in about 45 minutes. So if you are interested in that, please attend and stay tuned for the next things. Thank you.
Thank you, Latara.
Of course. All right. Well, it seems that there are no more other questions, so let's go ahead and and close. Fabio here says GG. Yes. Fantastic.
Thank you, Fabio. He's a gamer.
Yeah, and thank you so much for your contribution. We're happy to have had this workshop. Even as a non-developer, I found it interesting.
Let's see, next year maybe you're a game developer.
Yeah, we'll see.
Who knows?
It could be.
Thank you. See you next year at GoLab then.
Yeah. See you all next time. Thank you.
Bye-bye.
Bye.